today we'll be looking at jump if greater conditional. So let me open my file. So I'll name it maybe JG for jump greater. Then we'll go ahead and define our normal text section, then define our global start, then the start symbol. Now the jump if greater operation works the same as the jump if equal or jump if not equal, but to see it in action, let us move some numbers into some register. So EAX value like 20, like move into EBX the value 10. Then after doing that, you have to use the compare keyword or the CMP keyword. You compare EAX to EBX that way. So as you can remember what we said in the last two videos, the compare or the CMP keyword performs a subtraction operation and updates some flags inside the CPU. So in the case of this, it will take 20 minus 10, so which will give us a value 10. So this will update the 0 flag and the sign flag. So if this will be negative, the sign flag will be a 1, and if it will be positive, it will be a 0. And as you can remember, the 0 flag, any number that is a non-zero, it will remain as a 0. So it counts on these flags. So it counts on the sign flag and the 0 flag to be equal to 0. So that's just a short explanation, but let us see it in action. So let us maybe define our exit label. So move into EAX, the value 1 for system exit, move to EBX, the value 0, then let's do some interrupt over there. So again we have to define our jump if greater, so I will name it greater, just that way. And let us use some strings. So let me define another section which I will call data. So we'll define our message, so MSG. So we want a byte and we want greater, then followed by a new line, followed by a null terminator. So MSG len will get the length of that particular string, so MSG. Then we'll go ahead here, if it's greater we want to print that message. So as usual, we'll move to EAX 4, move to EBX 1, move to ECX, which value? The pointer to the data. Then we move to EDX, now the length, so MSG len. Then we do an interrupt as usual. So to use it, we have to use jump if greater. So this is the jump. It should jump if the comparison over here is EAX is greater than EBX. So let us just put a label here. So meaning, as you can see, this is greater because it doesn't result to a negative value or a 0. So let us run and see it running. So nasm elf32, then we named it like that. Then we want to generate an object file. Then we'll go ahead and link it. X86. So followed by the symbol, then followed by the binary that we want. Then after that, let me run it. So you can see it's greater. So if maybe we change something, let us change it to something like 5. So this will result to 5 minus 10, which will give us a negative number, so -5. So meaning the sign flag will be 1, and the 0 flag will remain 0, because the subtraction doesn't result to a 0. So let us see what will happen. So let me do that. So the same issue that we had in the last video. I told you that assembly runs from top to bottom. So because this value is not greater than EBX, it will not jump, else it will go to this part over here. But to short circuit it, you have to maybe if it is not greater, we jump straight to the exit symbol. So when we run it again, we don't hope to see something. We link it. You can see now there is nothing, and as you can see it has exited. If we look at the status code, we see it is a 0 over there. So this is the jump if greater, so you can use it. So there is another one called jump above. So jump if greater is used mostly for signed, if you're dealing with signed or negative numbers. And there is the jump above, which is used for unsigned, but we'll see the jump above in the next video. So if this video has been helpful to you, just leave a like, subscribe, and leave a comment, and I'll see you on the next video.